Alright everybody, in this video we are going to learn about some seismic hazards. The effects of earthquakes can be subdivided into two main groups right here: the primary effects and the secondary effects. The primary effects would be something related to the ground shaking or ground failure, or the deformation associated with the ground. And the secondary effect would be something that is not related to ground deformation, but something like liquefaction, landslides, tsunamis, or fires and floods would be considered as secondary effects of earthquakes. All right, this is the primary effect of an earthquake right here. Of Northridge 1994 earthquakes in California. It has about 6.7 magnitude. As you can see here, during earthquakes, the ground will accelerate both vertically and horizontally, as illustrated by this picture right here. And the intensity map shows the recorded areas with the most severe shaking. All right, and one thing that I want you to know is that the earthquakes do not kill people. Believe it or not, that the ground shaking or the ground motion will not kill people, but the collapsing buildings, they're the ones who kill people. Okay, so earthquakes and building designs are something that have been studied, in the past 10 years or so. Buildings should be designed to withstand maximum potential horizontal ground acceleration. In 2023, this is, a good example of how buildings can kill people. 2023 Turkey Syria earthquake claimed about 60,000 or more of lives, okay, and most of them are trapped under rubble that looks something like this. In 1976, we also had an earthquake in China at about 7.6 magnitude, okay, and there was about 1 million of people that live in this area, and 200,000 of them unfortunately died during the earthquake. And again, the earthquake hazard, some of them is the ground shaking. The ground shaking can cause these buildings to collapse, as you can imagine. These layers of things here, these are the different stories within that building that have been collapsed and just look like a pancake right there, okay? So the effect of horizontal acceleration on poorly constructed buildings can be seen by this on this picture right here. The rigid masonry structures may collapse and one floor on top of another one. And this is the picture from Mexico City in 1985 with a magnitude 8.1 earthquake. Mexico City is also known as a city where ground amplification can occur during earthquake. The reason for that is because this city was built on an ancient lake deposit consisting of unconsolidated sediments. So the sediments or the rocks are not fully compacted yet. Okay, so these geologic conditions could cause ground amplification to occur during earthquakes. Okay, so for example, this is a hard rocks right here, hard igneous rocks, and this is relatively hard sedimentary rocks, but alluvium and silt and mud typically are soft rocks, and they may have some moisture content within it, and these type of rocks, such as alluvium or silt and mud, these are the type of rocks that can amplified earthquakes and cause more damages during earthquakes because of the the soft behavior of these rocks. Okay, again, the interaction between soil and tall buildings led to increased resonance, or the building will start to sway even greater from earthquake, amplifying the effect of the earthquake itself. Okay, and again, this is Mexico City in 1985, where ground amplification occurred during the earthquake. Soft sediments can also cause something that we call as liquefaction. Okay, oops, again, sorry about that. Again, soft sediment can cause something to occur, which is called liquefactions. Liquefactions occur or typically associated with saturated, unconsolidated sediment that flows as a result of ground shaking. And typically, the high content of water within the rocks are the ones that cause liquefaction to occur. Okay. So, for example, we have liquefaction that occurred in 1989 in San Francisco because some of these rocks, especially the ones that are highlighted in orange right here, these are fill and bay fill and mud that typically have higher content of water in it. Okay, so this video right here actually shows how liquefaction occurs by Japanese scientists right here. So let's take a look at how this video illustrates liquefactions. So this scientist right here has a house model right there, and it sits on top of, it looks to me like a mud. The mud will have lots of water in it. Okay, so when you shake the ground, like during earthquakes, the water content will start to appear. There you go, you can see there. Then the ground will start to behave like a liquid, basically, and that is what we call as liquefaction. There you go. All right. Another secondary hazard that is very commonly happen is called landslides. Landslides are triggered by earthquake shaking in mountainous or hilly terrain. For example, these landslides right here happen after a major earthquake in El Salvador in 2001. This is also landslides that occur in Alaska after a major earthquake happened in 2002. And this one is an example from Yellowstone in 1959, where rock slid down foliation in schist that killed about 26 people in campground in Yellowstone. Fires are also something considered as the secondary effects of earthquakes. Okay, major secondary effects of earthquakes, such as happened in 1906 San Francisco earthquake, that they had fires burn in 3 days. Right, in 1923 we also had Tokyo earthquake. Tens of thousands of people died because of fire. So these are some of the things that cause secondary damages after an earthquake. Okay, so here is again another illustration of the San Francisco earthquake 1906 right here. Ruptured gas mains and lines that cause big fires to occur. Okay, San Francisco Loma Prieta earthquake in 1989 also caused some fire right there in Marina District. So again, fires are definitely one of the most devastating secondary effects of earthquakes. And the last one would be tsunamis. Tsunamis is a large wave caused by the sudden displacement of a large volume of water, and there's a sub-module for this. I'm not going to talk about that in this video. Please go ahead and learn about that in the other sub-module. All right, so I'll see you again in the next video. Bye-bye now.